Hey everyone, welcome. Today we're diving into something I think is super cool. We're talking about building robots that can navigate our homes, but, and this is the important part, do it without ever spying on us.
So, here's the big question, right? How do you build a smart robot that actually respects your privacy? We all want these helpful gadgets, but nobody wants a camera watching their every move. It's a real puzzle, but there's a solution.
The easy way out for a lot of companies is to just stick a camera on everything. Your robot vacuum, your smart display, you name it, it's probably got a camera. And sure, it works, but it also creates this massive privacy headache. It feels like you have to choose between having a smart device and keeping your life private. But what if that's a false choice? What if you could have both?
Well, that brings us to a really elegant solution. We're going to look at a technology that gives a robot a super detailed understanding of its surroundings. Basically, it can see without ever using a camera. Not one.
Okay, so the magic behind all this is something called a time-of-flight sensor, or TOF for short. The idea is actually incredibly simple. Think about it like this. If you shout hello in a big cave, you can kind of figure out how big it is based on how long it takes for the echo to bounce back, right? Well, this sensor does the exact same thing, but instead of your voice, it uses a tiny invisible pulse of light.
So how does this light echo actually work? Let's get into the nitty-gritty of how this laser-ranging tech does its thing.
It's actually a super quick four-step process. First, boom, the sensor shoots out a harmless little pulse of laser light. The instant it leaves, a high-speed timer starts. That light zips out, hits something, like your coffee table, and bounces right back. The second that light returns to the sensor, the timer stops. And since we know the speed of light, which is, crazy fast, the sensor can calculate the exact distance to that coffee table. It's so simple, but so effective.
And the tiny little component that makes all this happen is the VL53L1X sensor. This thing is the absolute star of the show. And when I say tiny, I'm not kidding. It's less than 5 millimeters long. It's so small, you could fit it pretty much anywhere on whatever robot you're designing.
Okay, so one sensor can see one single point in front of it. That's cool, but it's not exactly a view of a room, right? So how do we go from seeing one dot to seeing a whole 180-degree picture? Well, this is where it gets really clever. Instead of just one sensor, the demo system we're looking at uses a whole bunch of them. We're talking about an array of 9 of these little guys, all lined up in an arc, working together to cover a huge area.
But wait, it gets even better. Each of those 9 sensors doesn't just take one measurement. Nope, it actually scans its own little 20-degree slice of the world, and within that slice, it takes 13 separate distance readings. Talk about detail.
So let's do the math here. You've got 9 sensors, and each one is taking 13 measurements. That gives you a grand total of 117 data points in a single sweep. That's not just seeing an obstacle anymore. That's building a detailed digital map of the entire room. Now you might be thinking, wow, 117 measurements? That must take forever. But here's the secret sauce. Instead of the sensors taking turns, you go, then you go, then you go, which would be super slow, they all work at the same time. All 9 sensors fire and get the readings in parallel all at once.
And what does that simultaneous scanning get you? Pure, unadulterated speed. The system can create that entire 117-point map more than 6 times every single second. That's what we call real-time performance. It's fast enough for the robot to dodge a pet or avoid a chair leg as it moves.
All right, a 9-sensor system is seriously impressive, no doubt. But let's bring this back down to earth. How does this help us with a real-world project, like that DIY robot vacuum you've been wanting to build? Let's talk practical application.
And this is where we start thinking like engineers. For a robot vacuum, does it really need to see a full 180 degrees? Probably not. It mostly just needs to see what's directly in front of it. So that 9-sensor array is kind of overkill. We can scale it down to just 5 sensors. And that gives us a perfect 120 degrees of forward vision. It's all about using the right tool for the job.
So here's the perfect recipe for our DIY robot. We're talking 5 sensors for that sweet 120-degree view. We'll set the detection range to about 1 or 2 meters. That's perfect for seeing furniture nearby but not getting distracted by a wall way across the room. And the update rate? Somewhere between 5 and 8 frames per second is the absolute sweet spot for a robot that's cruising around at vacuuming speed.
Okay, so we've looked at the tech, we've seen how to apply it. Let's wrap it up and talk about exactly why this time-of-flight system is, frankly, a total winner for this kind of project.
First up, and this is a big one, the cost. Let's talk money.
This kind of multi-sensor setup is basically a solid-state LIDAR system. Now, normally when you hear LIDAR, you think expensive, but not here. Let's say your whole robot project has a budget of 100,000 rupees. This entire advanced navigation system, it comes in at under 8,500. That is less than 10% of your total budget for what is arguably the most important part of the robot. That's amazing.
And the benefits just keep piling up. You get total privacy, 0 cameras, ever. It's super cost-effective. We're talking about proven, real-world tech, not some experiment. You can tweak it for either more speed or more range, whatever you need. And because the sensors are so tiny, they're incredibly easy to design around. I mean, it just checks all the boxes, doesn't it? When you boil it all down, it's about one thing: balance. This system gives you the perfect balance of everything you need. You get great performance for a great price, and, most importantly, you never ever have to compromise on your privacy. It's the whole package. The bottom line is that this kind of powerful, privacy-first technology isn't locked away in some high-tech research lab anymore. It's here. It's accessible. It's affordable for hobbyists and builders like us. So that just leaves one big question. What are we going to build with it next?